Is the future of software development going to involve less human grind and more software actually building itself? Especially when you think about APIs, those complex communication lines that basically power everything online now. Well, today, we're diving deep into exactly that. We're looking at the, frankly, groundbreaking KN-codeIO API Specialist Engineer.
Yeah, this deep dive is all about unpacking this really autonomous agent. It's built like from the ground up to design, build, test, and deploy APIs, and with surprisingly little human touch needed. We've pulled together insights from, well, quite a few sources: detailed agent profiles, some comprehensive guides looking at its advanced features, and analyses of its actual benefits for teams. We're even looking at how it could, really shake things up for an AI division, maybe somewhere like BMW. So our mission today is pretty clear. Figure out what this agent is, exactly how it works, what it can actually do, which is impressive, and maybe most importantly, why it's such a potential game changer for software, especially for AI teams.
Get ready, because there may be a few surprises, some real aha moments about how automation is changing the tech world as we speak. Okay, so let's start with its core identity. What is this thing? It's collectively known as the KN-codeIO Agent Swarm. And its main job sounds, well, simple enough on the surface. Design, implement, test, document, scalable, modular, secure APIs. But the key is it's focused on REST, GraphQL, and WebSocket systems that are really critical stuff for modern apps. And what seems really vital is its role in autonomous agent orchestration, getting these systems truly production ready.
Exactly. And what's really interesting, I think, is that its mission goes beyond just building. It's about building correctly.
Yeah.
It actually requires that all the API logic follows these strict internal agent schemas.
Okay, schemas. Why is that so important?
Well, it means the agent understands standard patterns, right? So the output isn't just some random script. It's predictable, consistent, usable across the board. And everything it generates has to be fully observable, authenticated, and crucially, auto-documented.
Auto-documented. That's huge.
It really is. Think about DocsDrift, where the code changes, but the documentation doesn't.
Yeah, constant headache.
This agent basically eliminates that. New engineers can just jump in because the docs are generated with the code. No more chasing outdated wikis. And it's particularly good at building those endpoints needed for agent-to-agent talk, with things like rate limiting, security, and that auto-documentation built right in.
Okay, killing docs drift. That alone is a massive win for developer sanity, seriously. So you called it an agent swarm? That sounds like, well, more than one entity at work. How does that work, this sort of distributed intelligence? What are the different parts doing?
That's right. Our sources say it's made up of three very specialized subagents. You've got Critibot, NemoAgent, and TestBot.
Critibot, NemoAgent, TestBot. Okay.
Yeah. You can almost picture them as this elite autonomous engineering squad. Each one brings its own specific skill to the table, working together in this, well, automated process.
Right, like a specialized team. So with these different agents working together, what can the swarm actually do? Let's talk capabilities. What makes it like a super engineer? Starting with API engineering itself, it seems incredibly versatile, generating REST, GraphQL, WebSocket endpoints. It covers the main ways modern systems communicate, right?
Absolutely. And it's not just basic stuff. We're talking really quite sophisticated features needed for big enterprise applications. Things like multi-tenant scoped access.
Explain that a bit. Multi-tenant scoped access.
So imagine an app used by different companies or different departments. This agent can build the API to securely handle data for each one separately, using things like role-based access control or sandboxing to keep data isolated.
Got it. Crucial for security and privacy.
Definitely. And it also handles background job triggers, creates internal APIs for that agent-to-agent communication we mentioned. Plus, it supports things like API gateways and external API relays, all pretty essential for managing those complex microservice setups you see everywhere now.
Okay, that's comprehensive on the engineering side. But security, cyber threats are always evolving. How does this agent make sure security isn't just tacked on at the end? How is it built right in?
That's a really good question, and it's a core part of its design. The security is proactive, integrated right from the start. It manages the whole token lifecycle, making sure tokens are valid and only have the permissions they need. Scope control. It handles secret redaction in logs, which is vital. Stops sensitive stuff accidentally leaking out in diagnostics.
Yeah, that's easy to mess up manually.
Exactly. And it even does its own auth bypass testing. It actively looks for ways to break its own security before anyone else does.
Wow, okay. Testing its own defenses.
Yeah, and mitigation too. Plus, the standard but critical stuff like rate limiting and abuse protection against, DDoS attacks or bad actors. It's preventative, not just reactive.
That's definitely reassuring for any team.
Mm.
Okay, so we've got robust engineering, built-in security. What about the developers who have to use these APIs? Documentation and user experience, or UX, often the forgotten part. Does it really help developers?
Oh, absolutely. This is a huge win for developer productivity, or DX as people call it. It auto-generates OpenAPI and GraphQL documentation using standards like Swagger, OpenAPI Spec, GraphQL SDL.
So the docs always match the code.
Precisely. That headache of outdated guides. Gone. And it goes further. It gives you ready-made off-token instructions, setups for Postman or GraphQL Playground.
So you can test it immediately.
Instantly.
Yeah.
Makes it super easy for other developers to just start using the APIs. It can even optionally spit out client SDK blueprints.
SDK blueprints, like starter code for using the API.
Exactly. And it organizes everything in a developer-friendly folder structure, all designed to cut down the time it takes for someone new to get up to speed.
That sounds like a massive time saver. Okay. But complex systems. Things break. Monitoring is key. How does it handle observability and resilience? How do engineers know what's going on?
It tackles this head on. You get structured logging for every route, every action, makes debugging and watching things in real time much, much easier.
Structured logging. Okay. Not just random text dumps.
Right. And it provides key metrics out of the box.
Yeah.
Latency, load, even token usage. So engineers get this granular real-time view of how the API is performing. If you think about the bigger picture, it means you can trust the system not just to work, but to tell you how it's working. You can spot bottlenecks or issues before users even notice. Plus, there's optional integration with tools like Sentry for really detailed error tracing. Pinpoint the exact problem code.
Okay, comprehensive monitoring too. And then there's testing and validation. You mentioned TestBot. How rigorous is it? Does it really test like a seasoned QA engineer would? Or maybe even better.
It's exceptionally rigorous, actually. It goes beyond just checking if things work.
Yeah.
It does schema and I/O validation, obviously. But the really interesting part is fault injection.
Fault injection sounds disruptive.
It is, intentionally.
Yeah.
It deliberately introduces errors, network issues, slow responses, bad data to see how the system copes and recovers.
So it's testing resilience, not just correctness.
Exactly. It's a shift from does it work
Yeah.
to how well does it handle things when they go wrong, which they inevitably do, right?
Yeah.
It also tests for things like token expiry, malformed inputs, checks that secret redaction is actually working. It simulates edge cases, high concurrency, hits the rate limits, really stress tests the system. And it does end-to-end validation, checks the whole flow, inputs, outputs, failure paths, not just isolated bits.
Okay, so we know what it can do. Build, secure, document, monitor, test. Pretty impressive range. Now, the really fascinating part, how does it actually do all this on its own? What's the magic behind the curtain? This autonomous execution, the agent choreography. Let's get into that. It seems to operate on these core autonomous coding principles. It's not just following instructions. It sounds like it understands the why, like generating modular code for routes, validators, job handlers, enforcing strict types, being aware of those internal schemas you mentioned for consistency, and integrating the auto documentation pipelines right into the process. So docs aren't an afterthought. They're part of the build.
That's a good way to put it. And this all happens through a very specific 6-step execution cycle. Think of it as the agent execution loop. Those subagents we talked about play key roles here. First, step A, feature definition. The main KN-codeIO Agent Swarm defines what needs to be built.
Okay, so that's the goal.
Step B, critical audit. Critibot steps in, like a code reviewer, looking for potential problems, improvements, flaws in the plan.
The critic. Makes sense.
Step C, modular API generation plus docs. NemoAgent takes the audited plan and actually writes the code and the initial documentation.
The builder.
Step D, security test suite. TestBot comes in and hammers on it, runs all those security checks, fault injections, stress tests we discussed, tries to break it.
The tester. Very important.
Step E, refinement pass. The whole swarm looks at the results, focusing on things like scalability, clarity, performance optimizations based on the testing.
Polishing it up.
And finally, step F, delivery. If everything passes, it bundles it all up. Docker file for deployment, final docs, CI config. Ready to go.
Wow, that's a really structured cycle. And the choreography between the agents, you described it like a team conversation, each agent validating, extending, refining the work of the previous one. Not just a linear handoff, but almost iterative. KN-codeIO Swarm-Critibot-Nink's NemoAgent-TestBot potentially looping back.
Exactly. It's sequential, but with built-in checks and balances. Each agent acts as an autonomous checkpoint. It's a dialogue, like you said.
Yeah.
Critibot audits the initial plan. NemoAgent builds based on that audit. TestBot validates NemoAgent's work. and they can iterate if needed before final delivery. And this actually raises a really critical point about autonomous systems. How do they handle failure? What happens when something does go wrong in that cycle? That's where the escalation protocol comes in.
Ah, okay. So it has a plan for failure.
Yes, absolutely crucial for reliability. If a build fails or a test fails, the agent responsible is logged. Then TestBot and Critibot are automatically re-triggered. They try to reevaluate and fix the specific problem.
So it tries to self-heal.
It attempts automated recovery, yes. But if the failure persists after that second attempt, the whole pipeline stops. It won't push potentially bad code forward. It outputs a detailed error log instead.
Okay, so humans only get involved when the system genuinely can't fix itself.
Precisely.
Yeah.
Which drastically improves reliability and cuts down on the need for constant manual monitoring.
Right, this isn't just a cool tech demo then. Let's bring it back to the real world. What does this mean for a team under pressure? Like that AI team example, say, at BMW. How does this change their day-to-day and, well, their budget? Well, first off, you'd imagine the speed difference. An AI team at BMW, they're dealing with loads of data, constantly updating models for autonomous driving, personalization. This agent offers a seriously accelerated development and deployment cycle. Automating API creation means getting those AI models exposed as usable services way faster, streamlining that whole path to production, getting innovations out the door quicker.
Exactly. And importantly, that speed doesn't sacrifice quality. In fact, you get enhanced reliability and quality. Because of that rigorous testing, the fault injection, the stress tests, the APIs are built to be robust, to handle real-world conditions, millions of cars, users. And the built-in observability gives the team critical performance insights for those AI services. They can spot and fix issues proactively before they cause problems.
And for the other teams using these AI services within, say, BMW, it sounds like vastly improved collaboration and developer experience, DX. Those auto-generated docs, Swagger, GraphQL SDL, the SDK blueprints.
Yeah.
It just makes integration so much simpler for app developers, back-end teams. Everyone's working from the same, always correct playbook.
Definitely simplifies things. Then there's the huge area of built-in security and compliance. Those proactive security measures, token management, secret redaction, rate limiting, they're part of the design, not bolted on. For sensitive AI models and data, that's critical. It minimizes vulnerabilities, helps meet regulations, protects that valuable IP.
And maybe the biggest win for the engineers themselves, it lets them focus on core AI innovation. All that API boilerplate, the repetitive plumbing work, automated away, it frees up those highly skilled human engineers to actually focus on developing, training, refining the core AI algorithms, the stuff that really makes a difference for BMW.
And that shift in focus, combined with the automation itself, directly impacts the bottom line. It helps save money. Think about reduced development costs, automating generation, testing, docs. That's fewer human hours, lower operational spending. Simple as that.
Right. Less manual effort.
And minimize bugs and rework. The intense validation catches problems before deployment. That means far less costly debugging, patching, rollbacks later on. The escalation protocol stops bad stuff early. You also get lower maintenance overhead. Good auto-generated docs and structured logs make understanding and troubleshooting much easier down the line. Less cost for knowledge transfer, ongoing support.
Faster time to market, too, you mentioned. Getting AI products generating value sooner.
Absolutely. Faster development means faster revenue potential. And finally, optimize resource utilization. Efficient, observable APIs mean compute resources aren't wasted. That can lead to real savings on cloud infrastructure costs. It's not just speed, it's strategic financial efficiency.
Okay, so it delivers speed, quality, security, and cost savings. When it's done its work, what do you actually get? What are the final tangible outputs? It sounds like a complete package. You get modular REST, GraphQL, WebSocket APIs themselves, fully authenticated, fully observable endpoints. You get the auto-generated Swagger and GraphQL docs, a full test suite, PyTest, Jest, Supertest, whatever fits the stack, a Docker file, and a deployment guide ready for CI/CD pipelines, plus that SDK-ready client interface output compatible with agent choreography and internal tools. It seems pretty comprehensive. So wrapping this up, we've really dug into the KN-codeIO API Specialist Engineer today, and what emerges is, well, a genuinely comprehensive, automated, and secure way to handle API development. It really feels like it's pushing the boundaries of what autonomous systems can do in engineering. So what does this all mean for you listening? Well, it kind of makes you think, doesn't it? What does the future of software development look like when specialized AI agents like this one can take over entire complex workflows? Does it free up human engineers for purely creative work? For strategy? For tackling problems we haven't even thought of yet, the kind of automation we've talked about today, it suggests a future where human ingenuity is amplified, not replaced.
And that's definitely a future worth thinking about. Thank you for joining us on this deep dive into the future of autonomous engineering.